So we saw the graph on showing that cotangent theta and 1 over tangent theta were the same. And now we're going to look at verifying how to verify trigonometric identities. So work on one side of the equation. It's usually better to start with the more complex side, as it's easier to simplify than to build. Look for opportunities to factor expressions, square a binomial, or add fractions. Noting which functions are in the final expression, look for opportunities to use the identities to make the proper substitutions. If these steps do not yield the desired result, try converting all terms to sines and cosines, which is actually a pretty common approach. It's number 4. So let's verify that tangent theta times cosine theta is sine theta. So tangent theta, just recall, is going to be sine theta over cosine theta. So what we have here is that sine theta over cosine theta times cosine theta is sine theta. Well, cosines divide out and tells us that sine theta equals sine theta. That's it. Moving on. Verify the following equivalencies using the even-odd identities. So the key here is the sine of negative x. So we have 1 plus sine of x times 1, and sine of negative x is the negative of sine of x. So I'll do 1 minus sine of x. I want this to be cosine squared x. You probably already see where it's going. If I multiply this out, 1 plus sine x times 1 minus sine x, that's like a plus b times a minus b. It's just going to be 1 squared minus sine x squared, or 1 minus sine squared x equals cosine squared x. I mean, I kind of want to stop there, but if you want to go a step further, if we add sine squared x to both sides, what we have is 1 equals sine squared x plus cosine squared x. That's it. Okay, the next one. Verify the identity, secant squared theta minus 1 over secant squared theta is sine squared theta. Okay, so what we do have is the relationship that says that tangent squared theta plus 1 equals secant squared theta. So I'll use that and replace here. So I have tangent squared theta plus 1 minus the 1, that's this minus 1 here, over secant squared theta. So the 1s are going to subtract out, and we end up with tangent squared theta over secant squared theta. Okay, and tangent, well, this is like saying tangent squared theta times 1 over secant squared theta. Tangent squared theta is going to be sine squared theta over cosine squared theta. Secant squared, 1 over secant squared theta is just going to be cosine squared theta. So these divide out, and we're left with sine squared theta. That's it. Kind of fun. Next one. Create an identity for the expression 2 tangent theta secant theta by writing it strictly in terms of sine. Okay, so this is like saying 2 times, and then tangent is sine theta over cosine theta, and secant theta is 1 over cosine theta. So nothing's going to cancel yet, but we have 2 sine theta over cosine squared theta. So it's 2 sine theta over, and then cosine squared theta is, as we saw earlier, 1 minus sine squared theta. Okay, so everything we have now in terms is with sines, we have the constant, but sines. So we could say that 2 tangent theta secant theta is equal to 2 sine theta over 1 minus sine squared theta. There's your identity. Let's go down here. And now we have sine squared negative theta minus cosine squared of negative theta over sine of negative theta minus cosine of negative theta. So let's go ahead and look at each of these. So it's going to be cosine theta minus sine theta. So what I want to go through first is that we have basically sine of negative theta, and we're squaring that amount, minus cosine of negative theta. And we're going to square that amount. So we have sine of negative theta is the negative of sine theta, and we're going to square that amount, minus, and then the cosine of negative theta is just cosine of theta, and we're going to square that amount. So our numerator is going to become, and when we square this negative, it goes away. So it becomes sine squared theta minus cosine squared theta. And if you think about that, that's the difference of squares, so that would be like saying sine theta minus cosine theta times sine theta plus cosine theta. Okay, so let's bring it back to this other denominator. Now notice this denominator is sine of negative theta. So we have sine of negative theta minus cosine of negative theta. So this is like saying sine of negative theta is negative sine theta minus, and then we have cosine. Cosine of negative theta is just cosine theta. So this is going to be the negative of sine theta plus cosine theta. Okay, so let's put this together. What we have is a sine theta minus cosine theta times sine theta plus cosine theta over the negative of sine theta plus cosine theta. So that this divides out there. And what's left is this negative attaches to that numerator. The negative of sine theta minus cosine theta, which is like saying the negative of sine theta plus cosine theta if we distribute the negative, or cosine theta minus sine theta. Okay, I think it's kind of fun. And we have one more I want to do for this video. Now it's getting a little bit long. So we have 1 minus cosine squared x plus times 1 plus cotangent squared x equals 1. Okay, so if we think about the cotangent as a cosine squared over sine squared, we have our 1 minus cosine squared x times 1 plus cosine squared x over sine squared x. Okay, and then let's look at these terms here. I want to combine this. I have a goal here, and it actually centers around this part. I mean, the fact that 1 minus cosine squared x, let's give it to you now, is sine squared x. So if I can write this with sine squared as the denominator, then I'm going to have sine squared x over sine squared x plus cosine squared x over sine squared x. So I'm going to have sine squared x on the outside times sine squared x plus cosine squared x over sine squared x, because that's the common denominator. The sine squared x's divide out, and I'm left with sine squared x plus cosine squared x, and that's what? 1 by the identities. Okay, there we go, kind of fun.